All right, guys. So I did this one already, but actually my AC was a little bit too loud. It was like 85 degrees over here, but it's starting to cool off now. So hopefully I can get this done. It takes about 30 minutes to do the intro to state trees. So we're going to set this up in the next one. But in this one, I'm just going to do an overview with you. So we're going to create a folder. We're going to call it state tree, and we're just going to create a state tree here. Um, Actually, we kind of need an AI controller too. I guess we'll go ahead and create the AI controller in this one. So go to Blueprint, Class, and search for AI, AIC. I'm going to use the Detour Crowd AI controller because it has a slightly more advanced version of the RVO avoidance system, which the character movement component implements. It's based on the same principle, except it also takes the path finding into consideration as well. Uh, so I don't know exactly what the differences are, but I do know it's a slightly more advanced version. And we're just going to call this AIC and PC. And we'll go ahead and open up the character blueprint. And over here in the details under your class defaults, go to this gear icon and collapse all categories. Look for pawn, and then you'll see AI controller class here. And just select your AI NPC. You can switch this to placed in world or spawned if you want, but we only need it to be set to placed in world for this one because we won't be spawning them. So under here, we're just going to create a state tree. We'll just search for state. Don't put up space. It's space sensitive apparently. And we will just select one of them. It doesn't matter which. And select state tree component schema. And we'll just call this one ST and PC. You could call it STC if you really wanted to make it obvious that it's a state tree component. And so inside of your AI controller, we're going to add an AI. We're going to add a state tree. I'm not going to go over the perception system in this one. There are videos on that if you want to go and look at some of those, but we actually don't need that right now, so I'm not going to set it up. If I decide that we need it in one of the follow-up series on this, then I will probably cover that. But for now, I'm not going to because it's kind of aggravating to work with. Sometimes it can become corrupt, and so anyway. So when you've added a state tree component, you can select your state tree over here, STC NPC, and then just double click it. It'll open it, and you'll notice a few things over here. So I have a list. There's a lot of things to cover in this one, so I'm going to try to cover all of them. Okay, so the first thing I'm going to cover is children and siblings. So when you select this add state right here, it's going to automatically add it under the root. And that's a child state of the root. It's a child of the root. If you add another one, you'll see it also places it under. And it'll just keep placing it under. But if you want to add one that's a child of this state, then you'll have to right click and go to add state, add child state. Now in 5.5, you'll be able to select this and add a child or sibling right here from this button here. But currently, you can only add one by right clicking. And if I say add sibling, it'll make it a sibling of this one instead of a child. So I'm just going to call this an attack state. We're not actually going to hook up all this logic. I just want to show you all how this works. So I'm just setting up some stuff to show you. And so I'll say move into position, for example, attack target. Let's just say find cover. And so these are sibling states, and these are children of the attack state. So that's kind of how it works in behavior trees. Behavior trees work from left to right. These get evaluated from top to bottom. So whenever you enter the root state, it'll evaluate this one. It'll look at the enter condition. If it fails to enter the state for whatever reason, then it'll check this one. And if it fails to enter this one for whatever reason, it'll go back and it'll check this one. And by default, it's just going to spam you like this unless you offer some kind of transition that fails or succeeds the state. So because of this, what a lot of people will do is right here on the root, they'll add a transition, and they'll set this to on state failed, and they'll set the transition to tree failed. And what that means is that if we check all of these and we fail to enter both of these, instead of starting back over and doing this all over again, over and over, we're going to stop this tree, and this tree is going to stop executing. Okay? So that brings me over here to this side over here. And I'm actually going to start with types. So we have different types, and I'm just going to actually start over here on the attack state. We have a state containing tasks in child states. And you'll see a state has an enter condition, a task, and a transition. And then we have a group. A group is a state containing only children and no task. And so a group, by default, cannot execute a task. We have, let me go ahead and go over this a little bit more. So the difference between a state and a group. And also, it doesn't matter if this is a state in actuality, this is how it's going to treat it. So by default, a state with children, that brings us to our selection behavior. You know what? I'm going to put that off for a second. Let's just move on. So we have linked. So if we select linked, you'll see as linked subtree, and you'll see nothing shows up under here. Now, why? Because a linked is supposed to be linked to a subtree. And that brings us to subtrees. So if I make this find cover one, if I make this a subtree, and this is a linked one, then it will pull up the find cover, because that's the only subtree on this graph. If we make attack target a subtree, now find cover and attack target will both show up under here. Now, what's the point of this? If I have a parameter on attack target, for example, and this parameter was, say, attack successful, and let's just say it was true, okay? If we come over here to the attack state, if this is linked to the attack target, you'll see it also now has the parameter attack successful, and it is set to true. So whenever that variable is changed, it'll change on this one too. Whenever we change it here, it'll change here as well. And I'll go into more details about parameters and stuff like that here in a minute. So the last one is linked asset, and this is a newer one I haven't seen before until 5.4. I don't think it had anything to do with the plugins that we added. I think this is just a new type for state trees in 5.4. And basically, it allows you to link to another state tree asset to run an extension of this state. I'll have to explore this more further, but basically it allows you to link to other state trees. I'm not exactly sure how that works yet though, but you'll see these parameters here. If I link to this one, you'll see nothing happens, and that's because we don't have any parameters over here. So if I add a parameter, you'll see it doesn't show up over here, but if we reset this, let's see. Oh, I have to compile it. Okay, so attack state is linked to subtree attack target, which is not a subtree. Right, because we right. Yeah, we undid that. Right, because I said that. Okay, right. That makes sense. So let's just do it on this one so it doesn't get confused. So if I add this, and let's just compile it. Right, okay. We can't link to the same state, so we need to compile it first. Give me a second here. Bear with me. Once it's compiled successfully, then it should allow us. Okay, so see now you see this new property, and it has the same name and same default value. So let's just say we had 2 of these. Let's just say we had 2 of these. And it has a parameter still alive, for whatever reason it does. And so if we come back over here and we link to that one, you'll see it has that still alive property. And you'll see it compiles fine. It's not going to let you link to the same because that's an infinite loop. It's going to crash the game. So obviously it's not going to let you do that. I was just trying to show you this. And so you can actually change the value, the default value. I'm not sure what merit that holds, but I'm assuming that whenever you do this, it's going to create an instance of it. You're not actually changing this one specifically. So whenever state trees are set up on a player, they each get their own instance, which means that if you change a parameter in here, it's not going to change across all of them. Not as far as I know. I'm pretty sure these parameters are instance based, but I haven't really messed with the parameters much. But anyway, so you have your states, you have your grouped, your linked and subtrees, and then you have your linked assets now, which are new. So let's just go ahead and move on. So let me come over here to my little thing. I had to make notes for this. So selection behavior. That brings us to selection behavior. So I told you how a state has tasks in children, and then you have a state containing just children states. Now, the difference between a group and a state, at least whenever you're set up like this with this selection behavior, which is the default, try select children in order, that means that what it's going to do is whenever this intercondition for this state is evaluated, it's going to move on to the children, and it's going to try to execute the tasks on the children if their interconditions are successful. So what that means is that if you add a task, and a task, by the way, is what gets executed by that state. So if you want to move into position, you might have a move to task. If you have an attack target, you might have an attack task. So if you had some task like a delay task, for example, on the attack state, which is the parent of these 2 tasks, then what would happen is it would evaluate this intercondition, and let's just say this intercondition is object is valid, and this is something you might use pretty often. Let me come over here to the AI component, and I'm going to add a variable. And this brings us to something else here. And I'm going to call this one target. You can also call it current target or whatever. And this is going to be an actor. So let's say that your AI perceived a target, and that target was set to this target right here. But you only wanted to enter the attack state. If that target was valid, you're going to have to see. Oh, we need to set our context actor over here. My bad. I haven't gotten to that yet. I'm getting ahead of myself. I was trying to do things in a specific order, but okay, so your context actor class, that's basically the reference to the class that this state tree resides on. In this case, it's going to be the AI component, the AI controller, which is AIC and PC. So you don't actually have to set that, but if you want to be able to get access to these variables on it, then you need to. Now, if we come over here now on this object is valid, you'll see that it's saying that the object is valid, is expected to have a binding. And that's because it has this little marker here, which is gray, and it's called IN as an N. That means input. An input property is something that's expected, and I'll show y'all how to create input properties here after a while. There's 3 different types of properties. There's a context property, an input property, and an output property. Now, because we specifically set our context actor class to our AI component, we can now get the reference to that target from that actor. So we can go, this would be the actor itself, the reference to the actor itself. But if we move over the one with the arrow next to it, it'll pull up the properties under that actor, and we can select one of those. And so I want to select this target. And so this means that if this target is valid, then we can enter this state. And now I can compile it, and it'll be successful. Remember that the ones that have this input marker on them, those are required. That means that you have to give them a reference to something. You can't just set them. You have to give them a reference. So normally what happens is, like on a child state, for example, on this one, if the enter condition is valid, so for example, if the object is valid, check returned true, and that was on this, and we had a task under here, the move to task, then our character would be moved to that position. And then whenever that task is completed, it should normally, in most cases, return a notification that tells the state tree that it's done. And when it's done, that's when the transition occurs. So in this case, because this is a parent state, this enter condition will be executed, but this task will not, because of our selection behavior. So our selection behavior by default is set to try select children in order. If these 2 states fail to execute for whatever reason, then this task will get executed. So it's important for you to note that. If you want it to act differently, then you have to change its selection behavior. So instead of selecting the children in order first, from top to bottom, we could say try enter. And what this means is that even if it has children, we want it to execute this task instead. If by default, after this task is executed, it will not enter this state. So if you don't give it a transition, it won't go nowhere. It'll look like it got stuck. So a lot of people thought this was a bug. I was one of them, but it's not. If you don't give it a transition state, it will not transition. Now, by default, like I said, it will not transition to the children. So don't think that you can add a transition to and select next state and it'll just transition to this, because this is not the next state. This is a child state. This is an inner state. So the next state would be find to cover, which means that it would skip these two and it would go straight to find cover. Okay? So just know that if you enter this state and you set the transition to be the next state, it's going to move to the next sibling state, not the next child. So that's try enter. If you do the try follow transition, it'll just skip the enter and the task and it'll move straight to the transition. I'm not real sure what purpose that would serve, but I'm sure there's probably a few floating around there somewhere. But that moves us on to, we're going to skip tasks for now. I want to move on to transitions. We have multiple trigger types. We have an on state completed, on state succeeded, on state failed, on tick, on event. So on event gets fired by some kind of event. I'm not exactly sure how this works, but it has something to do with the event tags, I guess. Maybe there's a way to bind this to events. I'm not sure. So I'm not going to go over this one, but I'll go over the other ones. On state completed will fire if it succeeded or failed. You know what? It'll make more sense if we go over tasks first. So I'm going to go ahead and go over tasks. I'm going to go ahead and create a task. If you want to go to Blueprint class and just type in state tree, you'll see all the stuff that you can create for the state tree. You can create your own conditions, evaluators, and tasks. A task can be executed from global tasks or from a state task. An intercondition or a state tree condition can be executed from interconditions or from the conditions under the transitions. The evaluators can only be executed from the evaluators. I'll go over those here in a minute. Right now, we're going to go over state tree tasks. So I'll create that. Now you open it up and you'll see that we have 4 overrideable functions. If you press this override, you'll see these states right here. The only one you really need to worry about right now is enter state. You have exit state, state completed, and event tick. In most cases, you can get away without using the event tick. I would probably recommend doing that. Getting away without using the tick on the state itself, unless you actually need to. In some cases, you might actually need to. Now, an exit state only gets executed whenever we exit this state. State completed, obviously, when the state is completed. Failed or succeeded, it doesn't matter. But in most cases, you're going to be using this enter state. And if it fails or succeeds, you need to do a finish task. And you need to tell if it failed or succeeded. So let's just say that we have some variable. Let's just say, you know what? I'll just go ahead and go over all of this. So you can have 3 different types of variables. Remember I told you can have a context, an input, and an output. So I'll go ahead and go over that. We'll go ahead and type in an actor. Now, if you want it to be a context, what a context is for is if you come over here and you see this category called context, you can actually directly link to these context actors without having to set them manually from over here, you see. So you can actually have them automatically link to these. And that doesn't matter if you're on a gameplay interaction or a state tree component or whatever, anything under this context. If you put it under the context category, it's of the same type and it's got the same name, it'll automatically link to it. There might be some exceptions to that. I don't know for sure if you have to have the exact same name, but I've been giving them the same name. So, I mean, it just makes sense to me to make everything match. So if we just make an actor variable and we name it actor, by default, it will not link automatically. We have to actually put it under a category called context. And you don't have to expose this variable if it's under the context category. If it's not under a category of context, input, or output, then you need to expose it manually by making it instance editable. Otherwise, it will not show up in here. So if we go to tasks and we choose that STT test, actually I haven't compiled it, so let's just go ahead and finish setting this up. So let's say I want to do an is valid check. And in actuality, we could actually do it like this. We could use the pure function version right here. We could just pass that in. And so if it is valid, it'll finish successfully. If it's invalid, it'll fail. If it fails, that means, let me compile this. Okay, so see now you'll see that actor context. And it shows that that link right there. That means it's connected to the context actor, this one right here. So if it succeeds, then onState succeeded will be triggered. If it failed, onState failed will be triggered. So that's what this is for. And that's what it means to succeed or fail at executing a state. It's talking about this task right here. If we choose onState completed gets executed regardless if we succeeded or failed. The on tick will happen every single tick. And that allows us to jump to some specific state. And let's just say it's find cover. If for some reason some variable happens, okay, if some variable became true, then it will transition into this find cover state. And that's how that works. So that is actually somewhat useful. For example, if you want to ever immediately exit the attack state, if our target ever becomes invalid, if the target ever becomes invalid, then we want to exit the attack state. But these enter conditions only get checked whenever we enter the state. It doesn't get checked as the state is executed. So if we execute this, and then we have it transition back into itself, let's just say it was successful, then we could go back to the attack state. We could make it transition back to the attack state. And so if it was successful at attacking the target, we'll go back to the attack state and it will reevaluate the enter condition. But if we're moving to the position and suddenly we lose sight of the target, we don't want to keep walking to that position, or we don't want to keep trying to attack the target. Maybe we want to immediately stop and have them go to some other state, like look for target or whatever. So that's how that would work. Let me see here. I think I've covered quite a bit of it here. So enter conditions, tasks, transitions, context actor, I just covered that. So parameters. So I see we created a parameter. I don't even remember if we went over it. So anyway, so I created a parameter over here. And let's just say it's should look for target or whatever. And by default, it's, oh yeah, I did go over that. I went over that whenever we were going over this. Yeah, that's right. Okay. So I don't need to go over parameters. Okay, evaluators, let's see. I went over this too, didn't I? I believe so. Whenever I was going over subtrees, I went over parameters. I'll go ahead and go over it again just in case. So I have this find cover set up as a subtree. That probably wouldn't be the case in real life, but we'll set this to linked and we'll link it to the find cover. If we add a parameter under here, then we can, let's just say this in cover, and we could set that to true or false. So over here, we could, let's say we want to do an enter condition, and we only want to enter this state if the in cover parameter is false. So if this is unchecked, that means it's false, and it's going to compare this left against this right. So in this case, if that find cover in cover parameter is false, then we will enter this attack state. Okay, that means that the task itself would get executed if it had a task. Actually, linked tasks seem to not have tasks, which means that you'd have to add a child state. Yeah. So also, I wanted to show you this too. I think I've already went over this, but I'll go over this again anyway. So children can't actually access any variables on the parents, which means I should be able to access that in cover parameter. So if I come over here to this attack target, I can say in cover, and I can actually check that again inside of here. But I'm not just limited to using it inside of here. I can also use it inside of my tasks. Let's just say, for some stupid reason, I wanted to indefinitely delay this forever if the if the NPC was in cover. So if the NPC was in cover and for some reason we go into the attack target state and it executes this, then this would delay it indefinitely. If you don't have interconditions, it will automatically enter them. That means the intercondition will automatically be true because there is no intercondition. But if you have no transition condition, normally it'll default to the parent state, which will be this one. And then maybe this one will be executed, which will move us over to the attack state. Because this is a linked subtree, we can't set its selection behavior to try enter, which means that it won't try to execute a task on it because there aren't tasks for linked states. So you don't really have to worry about that. So that's almost it, actually. I'm not going to go over global tasks really, but it allows you to execute tasks globally. Not really sure what those are for, but those probably go back to these parameters. So you see these parameters here. Let's just say I add an actor. I should be able to pull this up now. So under parameters, new property, see, if I turn this to, let's just say it's called targets for whatever reason, then now we have this targets parameter set as the parameter that gets passed into this. So just because this is a context actor and it's automatically linked to this doesn't mean that you can't pass in other actors as well. You can. So I guess that's what these parameters are really good for, is global tasks. But also you can access them over here. I don't think you can actually manipulate these parameters from over here. I think maybe you can. I've tried doing it a few times, and for some reason it didn't really seem to work. So I'm not really sure if maybe that was a bug in 5.3. I've not tried that in 5.4. But the evaluators, I'll go ahead and go over that. So that basically allows you to execute whenever this state first starts. So when we first enter this state, it'll fire a task on the evaluator, and when we stop executing the state, it'll also fire another one. And then there's a third one that allows us to evaluate, evaluate whatever on a tick. So if we go to Blueprint, State Tree, and we select this, then you'll see we have 3 overridables. When the tree stops, when the tree starts, and then every tick. Self-explanatory. So also we can create our own conditions. So I'll go ahead and show you that. And there's only one overridable, receive test condition. Okay. Now the same rule applies for all 3 of these. Again, we have our context category, our input, and our output. If you don't put them under a category, like I said, they will not show up unless you make them instance editable. And I'll just go ahead and show that to you. So if I have this one, visible bull, and I'll call this one invisible bull, and then I'll call this one context. Well, that's not actually right. I'll just say actor. And you already actually know this one will show up. But let's just say this one is input bull. And we'll make this a bull. And then we'll make another one. We'll call it output bull. And I'll put this one under the input category, output category. And this one will be under the context category. And now remember, this one's not set to instance editable, but this other one is. So now if I come back over here and I add an enter condition, if you add a second enter condition, and this will be something else you'll learn. So if you see this new blueprint, it's because I didn't name it. And actually, I'm going to go ahead and show you something else here too. So I'm going to call this one state tree condition. I don't like that. That's the same as STC. I don't know. I'll just say ST condition for right now, and I'll call this one test. I'm going to show you something else too. If you go to class settings, under blueprint category, you can type in custom. And if right between the enter button and the backspace button, you'll see a backslash, and above that backslash is a bar. If you hold down shift and press that backslash, it'll put in that bar. And what that does is it tells Unreal that you want this to be a subcategory. So this is more common known than what it used to be, but there's still a lot of people out there that don't know about this. So if I say custom and I'll say smart objects, or actually let's just say testing, and I'll call this one conditional test, and I'll save and compile this, and I come back over here. Now I can come over here and you'll see I have this custom category, and under that custom category I have the testing, and then I have the conditional test. And you'll see right here that it says and. That means if this and that, if this is true and that is true, then enter. We can also make this or, which means if this or this, then enter. And now you'll see that we did not make these three right here instance editable, but we did make this one instance editable. This one isn't under a category though, but you'll remember neither was this one. So if you're not under a category, it has to be set to instance editable or it will not show up. So we can set this to whatever. You don't have to set context actors though. They automatically get linked. Like I said, as long as their names are the same as the context actor over here. And you'll see that we'll use that later too, whenever we start working with gameplay interactions, because it has more than just one context actor over here. So yeah, that pretty much sums it up, guys. I hope I covered everything. I hope you understand. And if you have any questions, feel free to ask. I could do a follow-up video later on. I don't really know much about debugging. Honestly, it's really confusing to me. I don't like the way it's set up, but I'm starting to understand it. So if you do have any questions about it, I'll try to answer your questions about the debugger, but it's kind of janky and I don't like the way it's laid out. So anyway, I will see you guys in the next video.